About time to get started. Hello, everybody. My name is Tyler Barton, and I am the program manager for the Bandwidth Optimization Services Group in Windows Networking, and I've come over here from Seattle. Little jet lagged. I don't know when to eat, when to sleep, but I do know when to show up for my talk, and that's a good thing, so here I am. I get to talk to you about two things today. The first is, well, I'm actually going to talk about this second, but the first is my baby, and that's BranchCache. I am the program manager for the engineering team that builds the technology. And second, I get to talk to you about the cross-premise capabilities that we have in Windows Server 2012. So you might ask, well, why are we talking about both of these things in one session? And it's because both of them should be interesting to the same set of people. If you are connecting to the cloud and you're moving some kind of workload off of your LAN and up into the clouds, you've got two problems that you have to contend with. First of all, when you move something far away, you've got to be able to connect to it. If you don't have connectivity, you don't have much. Once you've established connectivity to the cloud, then you have to contend with the added latency and bandwidth constraints of introducing wide area networking into the mix. And so the two technologies that I have to talk to you about today address those two needs and can be used together to make it simple to set up cross-premise connectivity and do some networking for the hybrid cloud. OK, let me start by motivating this, why we feel this is important. So does anybody remember when networking was simple? I mean, actually, I don't. Like, I do remember back in the day being able to follow the cable from a client up into the rafters, down the hall to the server at the other end of the room, and I remember it ending there. But I also remember that being a full-time job for a lot of people, just managing that. And now, if we fast forward into the modern day, jump into the year 2012, even before you leave the building, networking is a lot more complicated than it used to be. I'm sure some of the people in the room are running something that looks like a private cloud in headquarters right now. Some of the stuff that's going on those wires is quite a bit more complex than what we had many years ago. Then the rest of you are probably connecting up that location to servers that are far away over the internet, and you probably have more than one location. So this dramatically increases the complexity of the networking that we have to deal with. And then the rest of you have got a situation that looks more like this, where we've got a ton of locations that have all got to get connected up. And all those connections, we've got to make them secure. And we've got to pay for all of them. Connectivity is not free. We pay for capacity. We pay for bandwidth. Perhaps more importantly, when people are waiting for downloads, we pay for the lost productivity. So when our networks are slow, we pay for the time that people aren't spending working. So let's do something about it and make them faster. So the combination of solutions that I have for you today are designed to take all of that complicated networking, take this big mess, make it simple, make it fast, and make it inexpensive. So I've got two parts to my talk. I guess before I get into that, let me just show you a little introduction to the solution that we have. Here we've got a couple of different locations, and we're going to send up that URA up there stands for Unified Remote Access Gateway. And this is something kind of new in Server 2012. We took some old stuff, put it together, made it better. We're going to put one of those in each one of our locations, and we're going to use it to connect everybody up. And then when we have one of those things set up in each place, the bytes are going to flow, and a lot of them are probably going to flow. So we're going to set up BranchCache to take some of that congestion out of the network and speed things up for your people. That's what we're talking about today. So two parts to the talk. The first one's kind of short. We're going to talk about cross-premise connectivity, and we'll reference some of the other talks that are happening here at TechEd, direct access, network virtualization. And then we're going to jump into BranchCache, focusing on the stuff that's new in Windows 8 and Windows Server 2012. Had a lot of questions at the booth. Hey, what's new? We did a lot of stuff, and this is my chance to tell you about it. OK, let's start off with cross-premise connectivity. So what do we begin with? We started by simplifying remote access and cross-premise connectivity. So before 2012, maybe a year ago, this is what networking looked like for most people. You had a box that enabled remote access, and you had a separate box that enabled cross-premise connectivity. Well, to make things simpler, we moved both of those into the same Windows Server role. So if you go poking around with the bits that you have right now, you'll find that you can enable remote access, and you can do both of these things with a single server. OK, some scenarios, some types of connectivity that you can set up with this URA thing. So first of all, guess what? You can establish cross-prem connectivity. So this thing can give you site-to-site VPN type of functionality. It can also give you remote access. So this thing can act as a direct access server and serve your mobile clients. And then here's where it gets cool. This thing can provide connectivity to the cloud. if we set up one of these remote access gateways in a hoster's network, we can move some of our subnets into the cloud, and we can move a service while keeping all of the networking stable. That's something new. Okay, some requirements, some things that we had in mind when we engineered this thing. So the very first thing, what we were really focused on, was keeping it simple. Like I said earlier, networking is really complicated, and we want this to be easy because you've got a lot of places to get connected up. Okay, second, we want to make sure that all of your communication remains secure. Right? You're using wires that you may or may not own. We don't want you handing out data to bad people and using them. Okay, then the other thing, I talked about this just a second ago, we want to make it easy to migrate subnets and keep your network stable while you move things around. Right? Because an IP address is more than just a number. Right? A lot of systems depend on the network being one way or another. And if you can hide it all underneath with a good solution, you can prevent things from breaking. Okay, the other thing, this technology that we've built, we kept the needs of hosters in mind while we were building this as well. So the first thing, AAA, we want to make sure that that's possible. The solution that we have, it scales up and out, so you can deploy multiple remote access gateways that are fault tolerant and load balance. Here's a good one, interoperability. These gateways that we have can interoperate with the popular devices that are already out there. So we're not going to rip out all of the stuff that's already in place providing connectivity. With Ike v2, we can interoperate with the Ciscos and Junipers of the world. So you don't have to change what's already out there. Okay, and the last thing, customer tenant isolation. If you're a hoster, and there may be one or two in the room, or if you work with a hoster, that person is likely to want to support multiple customers. And those multiple customers likely have colliding IP address spaces. So with our solution with Windows, we can tolerate that. It's possible for one person to deal with multiple customers with the solutions that we've got in 2012. Okay, I said we want to keep it simple. This is what it looks like, and we'll do it live in a little bit too. Although I will say, my machine's a little jet lagged too. It's giving me a little hard time right now. Actually, it's probably me. It's usually user error, right? All right, you want to set up URA and provide connectivity. You can do it with PowerShell. And you can do it with one PowerShell commandlet. This is an example of an invocation of our PowerShell commandlet that's going to set up connectivity between two sites. And this is all that's necessary. Now, if you want, if you're a GUI type of person, and I guess these are becoming fewer and fewer, this PowerShell thing seems pretty popular, you can do that too. You can basically take the parameters that you'd pass into this PowerShell commandlet and stick them into a couple of different screens that we have. So here's one, here's two, and here's three. And this is what's necessary to set up connectivity between two sites. And this is something that we'll demo in a few minutes. Okay. A couple of properties of this unified remote access thing that we have. So the first is interoperability with Ike v2. So I mentioned this a moment ago. Our service can interoperate with a lot of other things out there through Ike v2. We support a bunch of auth mechanisms, EAP, shared secret, and machine certs. So all that stuff is in the box. If you didn't believe it was easy by now, well, I guess the demo will be what we try and convince you with. Man, I keep bringing this up. Dynamic distribution of routes. So you can change your network and move things around between your different sites or in the hoster's network. And if you've set everything up, you're sharing routing information between the gateways and between your routers. You don't have to do anything else. That's it. The network will take care of itself. The solution is IPv6 ready. So if you're there, that's excellent. If you're not, in time, we'll work with native IPv6. And of course, we work with tunneled v6 and v4. So the solution works with that stuff. Let me cover these two in sort of one I suppose, statement. So we support the deployment of multiple gateways in any one given site. We load balance between them. And we tolerate failure of a gateway. So if you've got two in two locations and one goes down, we'll direct all the traffic to the other. And it's possible for you to set up a topology where you have multiple locations in a mesh. You lose one of the connections, and the traffic will still flow around the others. So you can set this up to be highly available, to be load balanced, to tolerate failure. You can offload your encryption if you want. Whatever hardware you've got on your boxes, we're capable of using that. And the last one that I have here, VM-based deployment. So if you want this URA gateway, you can run this in a VM. If you're a hoster, you can run a lot of these, one per customer. And I hope you think that's good. OK, let's take this for a spin. I want to show a demo right away before my laptop gets cranky. I've got a whole lot of VMs on this machine. So this is what I've got the PowerPoint slide for. We've got a headquarters, and we've got a set of boxes that are going to provide unified remote access connectivity. Just got to get the title of my talk right. So what we want to do here is we're going to take one of our two app servers. In this case, it's got kind of a funky name. The reason for this is all this lines up with some of the hands-on labs we've got. We're going to take that one there. It's a mouthful, 2-app1, and we're going to move it far away. And then so that people can access it, we're going to enable connectivity between the two sites. And then we're going to test it out and take one of these clients and go and access that server that's remote. And we're going to do it with that PowerShell command that I showed you a minute ago. OK, let's do a demo. All right, so I wasn't lying. I do have a lot of VMs in this scenario. And in fact, I suppose I should say now, we're going to take this and we're going to extend the same demo and deploy BranchCache on top of it all. So what we're going to do right now is we're going to establish connectivity between two sites. And then later, in 20 or 30 minutes, we're going to deploy BranchCache to make the connectivity fast. So we're going to use the same set of computers here. OK. Can the cloud edge be Azure? So the cloud side can be anywhere that you can run this VM. I'm not quite sure about what Azure will give you right now, right? But any place where you can run this service and run our virtual networking. OK, so this one that I've got here, BC Cross-Prem, Corp Edge. We're going to turn this one into our Unified Remote Access Gateway. And we're going to use this, or we're going to work on this guy to hook up connectivity to the cloud. So here, we're looking at routing and remote access. And what we're going to do is I'm going to run that one PowerShell commandlet. And I've got it stuck in a script right now. And let me just show you this. The script there is called toCloud.ps1. Whoops. OK. So there, that's the content of our script. It's not so different from what I showed you in the PowerPoint slide a couple of minutes ago. We're using the same commandlet. The assembler parameters are a little different because the IP addresses in our demo are different. But we're going to run this thing. Let's do it. OK, it's going to take a second. And then when we're finished with this, OK, and that was quick. I didn't even get a chance to drink my coffee. I'm going to pop in here and refresh. And bam, there we go. There's our demand dial, site-to-site connection, ready to go. Actually, you know what? Sorry, to prove to you that this works, let me do this. I'm going to delete this. I'm getting ahead of myself here. Let's delete this guy. So we're going back to the beginning. OK. And I'm going to pop into one of my clients. OK, and let's test it out. I'm going to open up Internet Explorer. And we've got this all pre-rigged so that we can access app 1. This is local, remember. So this works, right? This is a server that's sitting in the one location connected to the same interface, the same vSwitch. And then this guy here, this is that 2-app1. And since I just deleted the interface, this doesn't work, right? This connectivity is not available. OK, so I'm going to run that script again. Sorry, this is the complete demo to show you that I'm not pulling the wool over your eyes. Let's pop back here into Corp Edge. I'm going to run that script again. I'm going to wait for just a second, and it's going to appear in the same place. OK, it was nice and quick. OK, there we go. We've got that site, the connection back up. Let's pop back into our client. OK, and let's go here, and we'll refresh this. And it loads. We now have connectivity. The demo used to be, we'd tell you about Washington and France, and we use some of the same stuff to show you multi-site DA and all that. But that's part of another talk. We can get complex another time. So there we go. We established cross-premise connectivity. It's one PowerShell commandlet. And we're going to move on and cover some of BranchCache. So I have another thing to insert here. That's it. So that's what it takes right now to basically enable a connection between two different locations. And now we're going to go on to the tech that I really love, which is making the network fast. And so that's BranchCache. OK. So what are we trying to do with BranchCache? It's kind of a basic thing, or problem that we're trying to solve. We're trying to turn this into this. We're putting a cache of data in the branch, trying to take some of the bytes off of the wire and improve performance for the people, for your people, speed things up a little bit. And we've got two different modes in which you can deploy BranchCache. I should preface this by saying I've got just a couple of slides on the tech that are true of what we initially shipped in Windows 7 and Server 2008 R2. So we're going to do just a little BranchCache remedial education, and then we're going to pop into all the new stuff. And we used to do 75-minute sessions just on BranchCache and stat. In fact, we do that a lot. So feel free to interrupt me if I'm skipping over some concept and you want to know what's going on. OK. So we're turning this into this. We've got two different modes in which we can deploy BranchCache. This one over here on the left, this is called our distributed cache mode. And here, clients share data between each other, and we don't need any kind of infrastructure in the office. So they just share, nothing else. On the other side there, we have our hosted cache mode. And in hosted cache mode, you set up a server in your branch office, and it holds on to everything and serves it to the clients that are there. All right, this is how our hosted cache mode works. So Bob comes into the office, 7:45 in the morning, fires up his laptop, and he goes to view something that's remote, access something on a remote file server or web server. We've got a few new workloads to tell you about later, but goes to access something that's remote. And his machine's going to make a request that's marked as being branch cache capable. If you're using HTTP, we've got our own content encoding. It's the way this works. So the server is going to see this, and instead of sending him all the data, he's going to send him identifiers, which are really small. And he uses these identifiers to contact the hosted cache server and ask, do you have the data that I'm looking for? Now, since he's the first person there, or the first person to request this, the cache server will say, no, I don't have what you want. So he'll go back over the WAN link, and he'll download the data. Now, when he's finished, he's going to offer the hosted cache this data, upload the IDs, and say, I've got content that other people are likely to want. So the hosted cache, he doesn't actually upload it. The hosted cache connects back to him at its leisure and downloads the data. It holds on to it. So Sally comes in 15 minutes later. She fires up her Windows 8 laptop, and she goes to view that same resource. She downloads the IDs, contacts the hosted cache server, pulls the data locally, saves a trip over the WAN link, saves a bunch of bandwidth. That's our hosted cache mode. OK, distributed cache mode. Two clients again, no hosted cache. Yes, sir? Oh, you're jumping to the good stuff already. So the question was, do we require enterprise server in the branch? And the answer is no. This will now work in server standard. So the hosted cache server is available in server standard. Good question. I was saving that one. Anyways, in distributed cache mode. OK. So the first client comes in. Let's stick with Bob. So Bob is going to go and view a resource that's remote, a website, something like that. And he'll download identifiers super fast. And then he's going to use those identifiers, and he's going to let out a multicast shout. So this is built on the WS Discovery protocol, little UDP probe. Look for another computer nearby that's already downloaded what he's looking for. Now, since he's the first person, he's not going to find anybody. So he'll go back over the WAN link and download the data. OK, 15 minutes later, Sally comes in, goes to view the same stuff, downloads identifiers very fast. She lets out a multicast shout. She finds Bob's PC and pulls the data from him. So that's our distributed cache mode. All right. Some people might ask, well, you've got these two modes. Which one should I use? When do I use which where? Well, I'd recommend that you use the hosted cache mode in any situation that you're willing to run a server in the remote location. And the reason is our hosted cache mode in general works better. If you've got something cached on your laptop and you close the lid and walk out, your computer is no longer available to serve the other people. So what we don't do with BranchCache is proactively push cache data to other clients. You only ever hold on to stuff that you have accessed and serve that to other people. So the hosted cache mode will give you better bandwidth savings and better application performance improvements. OK, a few things about scale. One of the areas that we've invested in Server 2012 is the scalability of BranchCache. The hosted cache mode will be able to serve offices that are much larger than distributed cache mode would be appropriate for. But we'll talk about that a little later. All right, so this is the last of the BranchCache remedial stuff that I want to cover. But it's a really important topic, and that's the security of our technology. So we're putting a cache in the branch, but we're very careful not to hand out the data that's cached to people that are not supposed to see it. And we have a model that lets us make this promise. You can enable BranchCache, but we're not going to hand things out, and this system doesn't make your network any less secure. So before I get into that, I'll cover the model. The first thing is, we're also capable of accelerating downloads that happen over end-to-end encrypted transports. So if you've got servers that are running, that are using TLS, or you're using IPsec, BranchCache still works. It has to do with the place that we're hooked into the networking stack. So we support encryption. We can accelerate encrypted downloads. Another thing, the cache data. This is also a feature. I'm getting ahead of myself. But we keep the cache encrypted. So if some of you have used BranchCache before, you might have noticed we kept the cache data in the clear. We changed that. New feature in Server 2012 and Windows 8. OK, let me talk you through our security model. This is how we make that promise that we're not going to hand out data to people that are not supposed to see it. By the way, feel free to interrupt me anytime. You guys are way too polite. Not used to this. All right, here's our security model. So we have a client, and he's going to request something of a remote server. Now, with BranchCache, we always, always, always make the client go to the content source before we access the cache. Part of that is so that we can make this guarantee that I just told you about. So the client's going to go to the content source. He's going to make a request. That request is going to be marked as being branch cache capable. So I'm just making sure my demo stays alive. It's going to be marked as being branch cache capable. The server is going to authenticate and authorize him the same way it would if branch cache weren't in the picture. So if he doesn't have access to this resource that he's trying to get, that's it. We're done. The server is going to respond the same way it would if branch cache weren't in the picture. Now, if this client does have access to view the file that he's trying to download, the server's he's going to take that data and cut it up into pieces and generate those identifiers I talked about earlier and ship those over the WAN link. So only if the client has access will he get the IDs. All right, so he gets those. Now what he does is he splits the identifiers into two different pieces, basically double hashes them. And so what he ends up with is a public identifier for the data and a private identifier for the data. He takes the public one and shouts that out on the network, and he uses that to find someone who's nearby. And when he finds that person, that other computer encrypts the data with the private ID before sending it to him. So the idea here is, if you're not able to access the original content, you can't get the identifiers, and without the identifiers, you can't make sense of what's in the cache. That's how it comes together. Yes, sir? Does it work together with dynamic access? So with dynamically generated content? Okay. In general, with branch cache, we won't interfere with whatever mechanism is governing content access. So if the permission to access a particular thing changes, that's fine, right? We're going to send hashes at whatever time the client makes the request and is able to access the content. So I'm not sure. I don't know the details of the technology together. But that's a general principle with branch cache. The same is true with file locking as well. We don't interfere with file locking at all. If you try and read something, you're subject to the same constraints that you would have been if branch cache weren't in the picture. Or you can't get identifiers for something that you can't read in general. So I hope that helps. OK. Any other questions about this? We're going to get into what's new. Yes, sir? Great question. So the question is, what about writing to a file? What happens in that case? Well, with branch cache, we don't actually cache on the write path. There are some tricks that some of the protocols can do, like when you upload to the remote server, also insert into the cache. But in general, with branch cache, we don't interfere with the writes. When you write to the remote source. So we also don't end up with consistency problems. But if you make a change to something that's remote, we won't serve you stale cache data. We never will. And the reason is, if you make a change to something that's far away, the identifiers for that data will also change, because the identifiers are based on hashes computed over the content. And those IDs don't match the stale content, and so you don't get served something that's incorrect. I hope that helps. Yes, sir?
With Excel sheets, in Excel you have a feature you can use shared sheets.
Uh-huh.
So when multiple people open it, is it also possible to use the branch cache, or is it always direct access?
So with Excel, right, when you write, you won't end up writing into the local branch cache. So I expect it will work fine, but all of the writes are going to be to the remote server. Now, there is a Windows 8 improvement that I'm going to cover in just a second that will give you some optimization in this case, where you're making small changes to a file that people are collaborating on, right? But we won't interfere with the write path, but we will be able to provide you some optimization when a file is changing across several concurrent editors. But I'm going to get to that in a second. It's actually coming up really, really soon. OK. Any other stuff on the security model, or just basics of how branch cache works with the identifiers and such? We good? OK. OK, on to the new stuff. So like I said, we used to do, or I often still do, we'll do 75-minute sessions just on the basis of the tech. But this is the three major areas that we've improved branch cache in Windows 8 and Server 2012. So the first is performance. The second one, we filed off the rough edges from our V1 release and added some new tools to make branch cache easier to manage. And then the last one is scale. So we pumped it up so you can use it in bigger offices. OK, let's start with performance. OK, the big thing that we did is we changed the way that we cut apart content. I went looking for the session, but I'm not quite sure that it's here or where it's being covered. You folks know about the deduplication work that we've done in Windows Server. So there's some stuff that we've done where we'll take all your files on disk, cut them up into pieces, and make sure that we're only storing each piece once. So we can deduplicate all the stuff that you're storing on disk and get a lot more virtual storage for every physical byte that you have. So what we did is we integrated with the file server team. They developed this technology for optimally cutting apart files, and we are using it in BranchCache to divide our content in a smarter way. So this is what we do. I mentioned earlier that we have identifiers. Well, what are those identifiers exactly? This slide you read from the bottom up. We take your data, and we run it through a fingerprinting function, the same way something like RDC does, but ours is a little different. We take your data, and we run it through a fingerprinting function, and this is like a mathematical, it's just a mathematical transformation, so we just change the data. And then what we do is we look for key points in this fingerprint function that become the boundaries of blocks. So this is how we divide your data. A very simple mechanism here is you look for local minima and maxima, so where the function is the biggest within a window. So anyways, those become the boundaries of the blocks. And then we take all of the data in one of those blocks, and we hash it up. It's truncated SHA-512. And those hashes become the basic identifiers for the pieces. So what we used to do, and I don't want to bash our old stuff because it worked pretty well, but what we used to do in 7 and Server 2008 R2 was we took your data and cut it up into big fixed size pieces. And then we subdivided those big fixed size pieces, but if you were looking for a chunk on a peer, you were looking for a big chunk, and it was a fixed size. And this meant that if you inserted a byte at the beginning of a really large file, all of the data was going to get moved along, and all the IDs were going to change, and we wasted some cache. And that sucks. So we changed it this time around. This way of doing things means we can isolate changes in your data. If you insert a byte at the beginning, the only thing that changes is the first block. And if the rest of it's cached, great. So we can tolerate small changes, and we can support collaborative scenarios where multiple people are working on the same thing, because one guy makes a change, but a lot of what's already in the cache is going to stay valid, provided he didn't alter the entire file. So BranchCache is way better for collaborative scenarios. Then the other thing you get out of this is we're much better at finding common pieces in totally different files. So you can have two files that have a big image in them. You download the one. When you go to download the second, we can share with the one that's already come down and speed that up as well. So in aggregate, the effectiveness of BranchCache depends a lot on the type of data that you're downloading and the access patterns. But what we do with Microsoft is we take large captures from our offices. We run a bunch of algorithms on them. And in most of our experiments, BranchCache shows the improvements in Windows 8 make BranchCache about 50% more effective than what we had in Windows 7. So this chunking model gives you an opportunity to save a lot more bandwidth. OK, that's the big thing that we did with perf. Right? Changed the way that we cut apart the content, made it a lot more sophisticated, save a lot more bandwidth, and support collaborative scenarios. OK, management. Sorry, I should say there were a few other minor perf things, little things that we filed off where we had opportunities to cache more, but I'm not going to cover them in this session. They're also pretty techy, pretty small. The big one that we did is changing the content division scheme. OK, management. Yes, sir?
One more question.
Of course.
Is it enough when I just replace the servers to the 12 and keep the clients running with Windows 7?
So it's a good question, right? It's about interop. The question is, if I only replace the clients and upgrade the servers. Oh, I'm sorry. Either way. No. So you need to have both Windows 8 and Server 2012 content servers. And the reason is the logic for dealing with the different types of division has to exist in both sides. We can't do it just one way or the other. The other reason is we have a lot more IDs that we look for now. And we had to do some serious perf tuning in order to deal with the added load and keep the impact of BranchCache neutral. And so a lot of that work went into the client. It happens to be what allows us to scale up, but we couldn't have gone with just the system that we had before. So we need to make changes in both products. Yes, sir?
Is it actually backwards compatible? So it's possible to have R2 and Windows 8 server working together?
Absolutely. So the question is there backwards compatibility? Any configuration of Windows 7, Windows 8, Server 2008 R2, 2012, hosted cache servers, content servers, clients, any configuration will work. If you don't have matching, you won't get the new content division scheme, but BranchCache continues to work. So it's not like updating your stuff is going to kill the value for your down-level clients. Good questions, guys. Yes, sir?
Is there any expiry time for the cache copy?
I'm sorry?
The cache copy will expire after a time, certain time?
Yeah. So what we do with the cache, with BranchCache, I hope you guys don't mind me taking questions as we go. It's because people forget otherwise, right? What do we do with the cache? So we reserve a chunk of your hard disk. By default, it's 5% of your active partition. And we fill that up. And once it's full, we start kicking out content on a least recently used basis. Now, the stuff that's in that cache can't live for more than 30 days. So no matter what, after 30 days, we kick something out. That happens to be something that you can change if you want. So you can make the client retain stuff forever if that's what you want, or you can dial it down. It's up to you. That's a configuration option, also new in Windows 8.
Is it possible to move the cache location onto a different partition?
Of course. You can move the cache wherever you want. You can change the size. OK, I'm going to continue. The basic principle with the changes that we made to our management model are we don't want you to have to do a lot of office-by-office configuration. So again, not to bang on what we built before, but you used to have to configure BranchCache in each one of your sites. Every place you wanted a hosted cache server, there had to be a group policy object and a certificate. And that, a few of you complained about that, and I understand. So we changed the way that you set this up, and we added a lot of auto-configuration and auto-discovery so that you don't have to do this. You can drive it with just one group policy object. And I'll demo this at the end. OK. So here we go. This is the first thing that we did. A hosted cache server can be auto-detected by clients. Didn't used to be that way. You used to have to supply the clients with the machine name of the cache server. And the way this works is when you deploy a hosted cache, you tell it, register your presence by establishing a service connection point. Some of you are probably familiar with this from Exchange. And the clients, when they start up, they'll go and search Active Directory for an SCP associated with their site, find the service, and use it. Now, you can deploy BranchCache in such a way that you tell your clients, try and find a cache server. If you find one locally, use it. If you don't, go peer-to-peer. Use distributed cache mode. So you put those two settings together, you deploy one group policy object, and the clients in your enterprise just figure out what to do. Yes, sir?
So are they based on Active Directory site? So does it need to, or is the server aware of the site?
It's not. It's based on AD sites. So the service connection point associates an AD site with the service. If you want to do subnet-based, you can link group policy objects to either security groups or what is it? I forget the exact mechanism, but there is a way to associate with IP address ranges as well, preferences. Good question. OK, so that's the first thing. We can auto-discover. Second one, changed our security a little bit. So I said this earlier. We didn't used to keep the cache encrypted. And this is kind of an engineering oddity from our first go with this. That's no longer the case. So we keep your data encrypted with the same level of security that we use when we transfer data between clients. So basically, we just keep data encrypted all the time. So your hosted cache server, it's always encrypted. It never looks at the contents of data the clients are putting or pulling from the machine. Now, the weird thing about this is it's actually a performance improvement because we skip an encryption-decryption phase. So this one was a total no-brainer and one of the first things that we did in Windows 8. Now, the byproduct of this is if you tried out BranchCache with Server 2008 R2 and you set up a hosted cache server, you had to put a cert on that machine for server auth, suitable for TLS. You don't have to do that anymore. It's just not necessary. So you can spin these up in the offices much faster and much more easily than you used to. All right, this is a new set of tools that we have. A lot of people asked for this. We now have capabilities for preloading the cache. So if you have data that's going to be on web servers or file servers, and you want it to be out there in advance, you can do that now. Now, the mechanism that we have is pretty open-ended. What we do is we provide PowerShell tools that you run on the content source. You take your data that you want to send over, you run it through our tools, we cut it up into pieces, and we package it all up in a file. Now it's up to you to get that package, that file, over to the remote site. We don't provide a mechanism for pushing it. But what this means is you can move it using any mechanism you want. If you've got a terabyte of videos that you don't want to pump over the WAN link, fine, you can stick it on a portable hard disk and FedEx it. Send it by mail, no problem. On the remote site, once you have the package, we provide you PowerShell tools that will digest that package, add it to the cache so that it's available for other people. So tools on both sides, one that takes content, turns it into a package, tool on the other side that eats the package and puts it in the cache. OK, you probably noticed there's PowerShell everywhere. I bet Jeff Snover probably talked about the number of new commandlets we have. Well, we contributed to that number. BranchCache is manageable through PowerShell and WMI, just like most other things in Windows Server. The nice thing that you get about this, with this, of course, is remote manageability. The syntax is nicer. It's all-around goodness. OK, last topic here, scale. Now, with Windows 7 and Server 2008 R2, we said you can only use BranchCache in an office of 100 people or less, no matter what mode you were running in. We've broken that, or we've changed that now. And the reason why we've changed this is because in 7 and R2, what we were really thinking about was branch offices connecting to headquarters. And now we realize that the problem, the space that we have to address, is actually a lot bigger than that. Because a lot of the time now, your servers are no longer at headquarters. They're off in the cloud. And what that means is your headquarters can benefit from network optimization as well. And at headquarters, a lot of you probably have a lot more than 100 people working. You can now use BranchCache in those large locations as well, and you can use it to get performance optimization when connecting to the cloud. We had to do the scale work to make that possible. So you can now use BranchCache in an office of any size. So the first thing we did, and this is to address that the interrupt question the gentleman in the back had earlier, one of the things that we had to do was we had to change some of the internals of BranchCache to make it more efficient. And we moved over to something called the Extensible Storage Engine. It's a database technology that backs up Exchange. And what this lets us do is store a whole lot more data and handle a lot more BranchCache load per unit of client or server disk and compute capacity. So we can store way more stuff and handle a lot more BranchCache communication than we used to be able to. Neat thing, a hosted cache server. Used to have trouble when it got over a couple hundred gigabytes of data. Hosted cache server can now store over 12 terabytes of data and keep up with pretty excessive client load, much higher than before. So if you've got a large location and you want to get a lot out of your network optimization technology, you want to be able to cache a lot of data. Because a lot of people access a lot of stuff and need to cache a lot of stuff. And that's now possible. A 2012 hosted cache server is way, way better at storing a lot more data than a Server 2008 R2 machine. So we're a lot more efficient, much better for large locations. OK, now if you have a super large location, where maybe you even have a really fat network, we have this now. We have the ability to use multiple hosted cache servers in a single site. Now, when I first came up with this, we said this was going to be some kind of hosted cache clustering. And a lot of people said, oh, that sounds like the worst idea ever. I don't want to cluster stuff in my branch office. And then we realized, well, we don't really have to call it that because we're not really clustering. The hosted cache servers don't need to be aware of each other. You set them up. They don't communicate. When a client starts up, it will detect there are multiple cache servers in my site, and it will spread the load across them itself. We already have a multi-download capability built into BranchCache from our peer-to-peer mode. We've just extended that for hosted cache mode now. So it's nice and simple. If you set up multiple servers and one of them goes down, fine, no problem. The clients will just move the load to the other. And when you set up multiple cache servers, it's the same process, just a couple of times in a row. So one PowerShell commandlet, be a hosted cache. Another PowerShell commandlet, you be a hosted cache. The two of them will work in concert. That's it. OK, let's do a demo. So this is what we had before. Provided all the VMs are still up and awake, that's a weird problem that I've been having. It looks like everything's good. So this is where we ended up before, right? We moved that 2-app1 server over into the cloud. We established connectivity. Now what we're going to do is we're going to make it fast. We're going to enable BranchCache using the new deployment model. And to do that, we're going to author a group policy object. So I'm actually going to show you what it takes to deploy BranchCache end-to-end. A little bit dry, but then we'll take it for a spin afterwards. So we're going to author that group policy object. And then what we're going to do is we're going to turn this machine, this guy here, this remote access gateway, we're going to turn him into a hosted cache server. Because you can run the hosted cache alongside other workloads just fine. It's not really computationally expensive. We just move blocks to and from the disk. So we're going to do that. And then we're going to try out BranchCache. We're going to take it for a spin on these two clients and show you the effect of caching and show you the new perf improvements. OK. OK, so back to my demo setup. So the first thing I'm going to do is I'm going to jump into my domain controller here. And let's author that group policy object that will enable BranchCache. So here I'm in group policy management. I'm going to create the object and link it to the domain root. And we'll call it enable BranchCache. I hope you guys can see this OK. It's kind of small. I'll try and talk through as much of this as I can. OK, so we created a new object, and we're going to edit it. And I'm going to jump to the BranchCache administrative template. Not preferences, policies, administrative templates, network, and then BranchCache. OK, there we are. So that's where we are. So the first thing that I have to do is this. I've got to turn on BranchCache. The technology is not on by default. You've got to opt in. So we'll turn it on. Okay. And then, do you remember earlier I said the best model to do this is you tell clients, try and find a cache server. Excuse me. If you find one, great. If not, use distributed cache mode. That's what we're going to set up right here. So I'm going to enable this setting. This setting is set branch cache, distributed cache mode. We're going to turn that on. Okay, so we enable that guy. And then here is a new setting, not this one, but this one. This one, if you can't read it, it's really small text. Enable automatic hosted cache discovery by service connection point. So that's the new auto discovery setting. And we're going to tell our clients to do that, to try and automatically find hosted cache servers. So we'll enable that guy. Okay. So that's it. That's the only branch cache config we're going to do. Some of you might notice there's a few other things in here that you can do, change the cache retention and all that. We're not going to do that in the demo, but there are a few more things that you can do with branch cache if you want, mostly in response to just feedback. Okay, the next thing I got to do is I need to alter the firewall to permit the flow of branch cache traffic. Again, a little dry, but we've got to do it to proceed with the demo. So I'm going to go here into security settings. And I'm going to go to Windows Firewall with Advanced Security. There we go. And I'm going to enable 2 inbound rules. So here's one here. Okay, and we've got predefined rules. Right, so new rule, predefined. Okay, so the first one we're going to do here is branch cache peer discovery. So this is just in case the clients have got to go peer-to-peer. We want to make sure that they can discover each other. We have a protocol for that. It enables multicast traffic on UDP port 3702. I'll just let that guy in. Okay. Oh, did I do something funky? Oh, allow the connection if it's secure. Let's just allow the connection. Okay, and then the other one I'm going to do is I'm going to enable content retrieval. So what this rule does, uses HTTP. This is going to allow branch cache clients and the branch cache hosted cache server to pull data from each other. Okay, so I've altered the firewall, I've enabled branch cache, and I've told the clients auto-configure themselves. That's it. That's the group policy object. We're done. So the clients are going to figure out what to do. All right, so the next thing I'm going to do is I'm going to pop into that Corp Edge machine. You remember we were here earlier, and so we're looking once again at the routing remote access. But I'm going to pop into PowerShell. Okay, and let me just clear this for us. I'm going to run one PowerShell commandlet that's going to turn this machine into a hosted cache server. So prior to the demo, I did do one thing, and that was I installed the branch cache feature on this machine because it's not installed by default. So I cheated a little bit. I did that. But I'm going to run this commandlet. It's enable EC hosted server. Okay. So that turns the machine into a hosted cache. And then I'm going to specify, I'm going to toss in this flag, and that's register SCP. So that tells this machine, be a hosted cache server and register your presence so the clients find you. That's it. This machine is now a hosted cache. Okay, let's take this for a spin. Let's go into the 2 clients. And there's one little thing that I've got to do first. Here, I'm going to close IE. I need to make sure that these clients get the group policy object that I just authored, right? So I'm just going to force a group policy update. You don't really have to do this, right, unless you're trying to demo the deployment model in 5 minutes. The clients will pick it up in time. But I need to. Okay, GP update. Okay, so we'll make those guys eat the policy. And now let's take it for a spin. So if you want, here, let me just show you one thing. Let's do this. There's a PowerShell commandlet, get species status. So if you run this commandlet, it'll give you a dump on the branch cache configuration. And if you go up to the top here, here we go. This machine is operating in hosted cache client mode, and it found the server that we just set up. So he's all set. Okay, now before I proceed, I want to show you how this is going to work. Let's jump into this Cloud App VM. This is that 2-app1, app 1. And what I'm doing here, this little window that I have open, this is slowing down connectivity to the machine. It's running a piece of network emulation software that we have at Microsoft. It's one of our internal tools called the Network Emulator for Windows Toolkit. And it's going to make connections to this machine seem as though they're coming over a 512 kilobit per second link with about 80 milliseconds of latency. So really slow link, but there's no traffic on that link. There's just the 2 clients. So this guy's going to seem like he's far away. Okay, I'm going to pop back here. Let's go into the first client. And let's go and pull up a website that's running on that machine. So it's going to take time to load up these images because, of course, nobody's downloaded them before. Now what I'm going to do is I'm going to go and save a file. Okay, let's save this. And we're going to have to wait for it to download. If you can't see this down here, 37, 44, 48, 52. It's about 1.7 megs. So somebody's got to wait for a little while in order to download this file and proceed. Okay, we're finished. So 1.7 megs. 20 seconds or so. All right, let's pop into the second client, and let's do the same thing. Let's open up Internet Explorer. Now, one thing about this demo, it's really nice when you got, okay, that's pretty fast. Sometimes when I load this page, the fact that I'm running a ton of VMs on one laptop kind of kills my mojo. But you can see it loaded up pretty quickly, and that's because we're able to pull the images from the cache. Now let's go and save that same file. All right, we'll download that guy. Okay, and wait, what? Sorry, guys, that's inconvenient. I might have mentioned earlier that, okay, all my machines are shutting off. So this is a little hiccup. That sucks. We're going to return. We're going to finish this, though. I'm not done. You know, I kind of feel like this is a practical joke. I had pretty good scores last time, and this is someone just trying to, you know. Actually, it's review season at Microsoft, too. Damn it. Anyhow. So I'm going to start these up in a second. I'm going to continue with my talk and then pop back in. So we're going to download that same file again. It's in the cache server. When I start all of this up again, it should work. And this is too bad because the very best part of the demo is just about to happen, but we're going to come back. Okay, so this guy is still shutting down, or he's running. So let me just start these guys up. Okay. Okay, I'm going to give them a second to start, but I'm going to proceed with the talk, and we're going to come back, okay? Do a quick refresh. So this is the demo setup, right? You remember this slide. We've set all this stuff up. And that was the demo introduction, I guess. Here's some stuff that's going on with BranchCache. So this is the look at the BranchCache platform. And there's a few new things on here. Unfortunately, there's some new stuff coming up that I just, you know, they keep my hands tied, and I can't tell you about it just yet. So BranchCache is a platform. We have APIs that ship in Windows. And we use those APIs to go and instrument protocols so they can take advantage of the cache. So basically, we've got two sets of APIs. We've got APIs that are used on the server and APIs that are used on the client. The ones on the server, if you've got something like a web server, takes data, pumps it into our APIs, and we hand back hashes. The hashes go over the WAN link, they go to the client, they go into the client APIs, and we do the search, retrieve, and come up. That's the way it works. So we use those APIs, this platform, to go and hook SMB and HTTP. And we did that back in 7 and Server 2008 R2. So those are the two basic protocols that eat most of the WAN bandwidth for most people. Right, so we hook those so they can use BranchCache. And what this means is any apps that you have that use those protocols between Windows servers and Windows clients that are BranchCache enabled, they benefit from the cache without requiring changes. So the apps are unmodified. So a couple examples there: Office, Copy File Explorer, Media Player, Internet Explorer, that kind of stuff. The BITS protocol is also hooked up, so if you use SCCM, WSUS, that kind of stuff, you have the opportunity to eliminate some distribution points and speed up that download. That stuff is highly cacheable, right? You have the same software update or the same package deployed to many people. You might as well cache it and serve it. Here's a new one. This is exciting. This is one of our new things that I can tell you about. Windows Intune uses the BranchCache platform. So if you're using Windows Intune to manage a whole bunch of clients, and you're pushing out the same piece of software, do a whole bunch of them over the internet, BranchCache will kick in and make it such that you only have to move the data once. All right. Then the green box there at the end, what this represents is that this is a platform in Windows, and we use it to hook up Windows protocols, but it can be used by other pieces of software as well. So we are working with a good number of partners to get other protocols beyond the ones that are hooked up in Windows to use BranchCache. So we've got HTTP, SMB, bits, and Intune, but there's a bunch more coming out, some from Microsoft, some not. So watch the BranchCache platform because there's new things that will speed up in time. Also, one last thing. I'm sure a lot of you are aware that we gave a talk to developers at the Build Windows conference, where we had a lot of talks, and included there was a BranchCache talk. If you're interested in this, we have a way that you can use BranchCache to speed up communication with a cloud blob storage like Azure Storage. There's a model for doing that, but it's a little techy. It requires writing a little bit of code. So if that sounds like something you'd be interested in, I think I've got a link to communicate with us at the end. There is a recording of that. We have a very technical talk on our platform that covers that. So I just want to make sure you're aware that you can do some sophisticated stuff with this. Okay. There's a few partners. Some of these people are here. Some of them are not, in fact, here. But these are people that are doing stuff with BranchCache. So let's start with F5. Their logo looks huge in comparison to the others. But F5 has got a module that's available right now that will do hash generation on their network load balancer. So if you've got a big IP, you can run this module that they have, and it will generate hashes on behalf of servers behind it. EMC and NetApp, I should cover them separately. EMC is going to support BranchCache in their VNX operating system. They are here. You can go talk to them about this. If you've got an EMC appliance, it will serve hashes, and it can be accelerated, or you can get acceleration when people are contacting it over a WAN link. That isn't available just yet, but it will be soon. You should go talk to them now if this is something you're interested in. N-Appliance is a partner of ours that is shipping a Server 2012-based appliance that will give you remote access, site-to-site connectivity, and will act as a hosted cache server. It actually does a lot of cool stuff, so they've got this in an appliance form factor. You should check it out if that's what you like. IVO Networks is an old partner of ours, and they have been around. They've got an appliance that acts as a hosted cache server as well. And then NetApp, so a very common question I get at these events is, well, what happens if I've got a non-Windows file server, if I'm using NetApp? Well, NetApp is releasing support for BranchCache in their ONTAP operating system coming out later this summer. They're here. You can talk to them about their BranchCache support, but their device is capable of serving hashes in the old scheme and the new scheme. We released our protocols a while ago, and they're really with it. So them and EMC, both of them. So if you've got non-Windows file servers and you care about BranchCache, go talk to those people. They're around, and they're releasing support very soon. So bunch of partners. Most of them do have a presence here. We've got a range beyond this as well, but this is just a little taste of the people that are here at TechEd that you should go talk to. And I think, OK, I'm going to go back to my demo, but this is Rand. Rand is not here right now, but Rand is a very old customer of BranchCache. He participated in our TAP program in Win 7 and Server 2008 R2, and this is a quote that he was kind enough to give us. It really comes down to this. This is not that hard to set up. Right? If you're using Windows, and certainly if you're using Windows Enterprise, BranchCache is there. You can deploy it really easily, and you can also take it for a spin really easily. If you want to set this up in a lab, it's no more complicated than the demo that I'm doing right now. And you probably will even have virtual machines that don't shut off randomly, so it'll be way easier. So do take it for a spin. That was Rand's message, that you can get WAN acceleration pretty easily. I'm sorry, which the? Oh, it's a role, and it's inbox. So the question is the unified remote access role. It's a consolidation of a few other roles that were there previously. So if you look at Server Manager, it's a role there called remote access. It's combined. So the direct access server used to be something separate. It's now part of the remote access role. So that one role provides a few different functionalities now. So that's how you deploy a DAS now with Server 2012. Is that helpful? Or no, I confused you more somehow, didn't I? I'm sorry.
I went to a session the other day
Which?
about direct access and how it works with now. And they call it access gateway. They call it unified access gateway. It's just a product.
Yeah, it's a role in Windows. It's not a. Yeah, you're good to go.
Actually, I think Microsoft right now confusing their customers because UAG and TMG will no longer the slide version be continued. And their last little session, I saw that as well, presenting UAG and TMG
Right.
information. But right now we see that direct access has moved to Windows 2012. And I don't know about TMG, but Windows has.
Oh, okay. I can't. You guys are trying to get me in trouble. I can't talk about TMG and UAG. I can tell you that the DA capabilities that were in them have moved inbox. Do you want to come talk to me afterwards? I am not the DA PM, but he is here. If you probably went and saw Sharad's session yesterday, and I'll make sure that you get the information you need. But remote access is a role in Server 2012. Why don't we just talk after the session, and we'll make sure we get everything ironed out. Okay. Yes, sir. Yeah, so that's an interesting question. Can you use BranchCache for internet access? BranchCache is not hooked up on a service like YouTube, right? At present, places where people are likely getting a lot of internet data, you're not serving hashes. What we do with HTTP is we have our own content encoding. If you were to look at a network capture, you'll see that when you contact a BranchCache resource, we use something called the peer-dist encoding. It's not gzip, not identity, deflate, it's peer-dist. And what we do is we transmit hashes in the body of the HTTP response. A lot of network infrastructure is OK with that. A few pieces of network infrastructure aren't. So it's possible that you've got a proxy, because there are a million different types of proxies that doesn't like that, and we'll just have a hard time with it and won't permit BranchCache. So there's nothing about BranchCache that prevents it from working over the internet, except that you may have an old proxy that's not HTTP compliant that will choke on it. So that's the only gotcha. Now what we're doing is some of the way that we're using BranchCache now insulates the hashes from network infrastructure. So the way Intune uses BranchCache, for example, Intune is a cloud service. It's designed to work over the internet. They're just taking the hashes, and instead of using the pure dist encoding, they're hiding it in their own protocol that's tunneled in HTTP. And that no network infrastructure has a problem with. It's fine. So it's possible that if you just enable it on a web server, toss it out there on the internet, and access it with BranchCache, you might have something in between that doesn't like it. So I've got to warn you. But otherwise, yes, it will work over the internet. It's one of the ways that we're reimagining BranchCache. It's not just for connectivity to headquarters. It's also for connectivity to the cloud. And in most cases, that's over the internet. Hope that helps. OK, should we go back to my demo? I mean, I have this weird thing where I don't practice this with the machines shutting off midway. But we were here a second ago. This is client 2. And you must forgive me. Oh, I'm sorry. Yeah, thank you. OK, great. So let's just pop into the desktop, and we're going to do that same thing. Everything should tolerate a reboot like that just fine. So let's go and access this resource. OK, guess what? This loads up super fast again because we're able to pull from the cache. Oh, actually, this is the other reason it's super fast. Let's go back into the cloud server, right? So what I've got to do here is I'm going to restart that network emulator. So we're going to slow down connectivity again. OK. So let's go back into client 2, and I'm just going to back this up a tiny bit. Let's just go into downloads here. Let's delete this. Actually, no, let me reset just a little further if you don't mind. This thing, I'm going to run a script on this computer. This one here that I've got on the desktop, it's called flush. It's just doing a few things. It's clearing the Internet Explorer cache, and it's flushing out the local BranchCache cache. And I'm doing this just so that we can back it up just a little bit. It's a little tool that we make for the purpose of the demo. OK, so we're flushed. We've removed everything. It's almost as though I've never logged onto this computer. OK, so let's load up IE. Boom, we're able to pull from BranchCache really quickly. Let's go and download this file, right, which we downloaded before. Right, it was downloaded by the first client and put on the hosted cache. So we save this, and it finishes immediately, right, because we're able to pull from the cache. So that's BranchCache working in its most basic mode. Now, here's the kicker. This is the fun bit. There's another file here that's totally different. So the first one there is 1.71 megabytes. It's a PPTX file. We have a .docx file that's an IT services white paper labeled. It's a fraction of a megabyte smaller, 1.69 megabytes. This has not been downloaded by anybody yet. Let's go and download it. OK, 292, boom, we're finished. That's a different file. You can see that it took just a fraction there to get it. That's our new performance improvement at play. So nobody's downloaded and cached that file before. What happened here is there's common content between the .docx file and the PPTX file. They both have a similar large image in there. And with the way that we changed our chunking model, we're able to isolate that image and use what was already downloaded in this separate document. So that's the Windows 8 improvement, speeding up the second download, even though it's totally unrelated. I am really glad I got a chance to show you guys that. It would have been unfortunate if I blew that part of my demo. So thank you for waiting it out with me. Sorry, the thunder was stolen a little bit. Sir, did you have a question about this? No, it's a general thing. So with the Office format, because of the hashing scheme. Right. We almost don't care what the format of the file is. We just divide it up. Now, it so happens with Office that Office is a zip file, right? And so the different boundaries of the zip document are the different pieces. So something like an image is going to exist as a unique thing in the Office file format. So we can isolate it pretty easily. But no, it does not have to be an Office file format. OK, I think I'm going to switch back to my deck, although I think I'm all done. These are some related sessions. So most of these have to do with cross-prem connectivity. So is the first one, no, where do we have direct access is the one in the middle. So this one's already happened. That's Sharad is a peer of mine. He gave the DA session yesterday. It was very popular. He will be hanging out at the booth an awful lot as well. So if you want to get hardcore about DA, He'll be there, and he's the person to talk to. If you have trouble reaching him, let's talk now. I want to make sure that we get your questions answered. So the other one here, Hyper-V Network Virtualization for Scalable Multi-Tenancy in Windows. This is my boss's boss, Sandeep, who's a great presenter. He's going to be talking about network virtualization tomorrow. It actually conflicts with another talk I'm giving, so I shouldn't pump this up so much. But go listen to what he has to say. If you're curious about that ability to move subnets around and virtualize the network, it should be a very cool talk. So a few related sections. I think that's it. Now, I do want to remind everybody about one way. Most people have got to get in touch with us and other resources and stuff. I'm just going to tell you one thing, www.branchcache.com. That will forward you to our TechNet site. You can find out anything you need about BranchCache. If you want to get in touch with us, you can also email branchcache@microsoft.com. I watch that alias like a hawk, and you'll get in touch with me, Tyler Barton, and I'm happy to answer any questions or tell you about our technology. Also, if you have feedback, contrary to what my ex-girlfriend says, I do listen, and I'm more than happy to hear what you have to tell me about the technology. That's actually how we put together a lot of our plan this time, was listening to folks like you that come to these kind of sessions. Further questions? Anybody have? Yes, sir, at the back?
Is there any way of making a metrics out of BranchCache?
You bet. You want to look at that? So there's a few things. We author a SCOM pack that you can use for aggregating data. And there's a few other ways that you can do this. We write some scripts that do it. Let's hop into Corp Edge here. And I'm just going to open up perfmon. OK, so let's take a look at the BranchCache performance counters, because they will have moved on this machine. So I'm going to add some counters. I hope the rest of you don't mind the little diversion here. It's a popular question. So bam, let's look at BranchCache. And we'll add those. OK, let's just change the report type. OK, here we go. So what you see here is counters counting a lot of stuff, but what you're principally interested in is pretty small. There are counters for the bytes that have come from the cache, the bytes that had to come from servers, and bytes that this server served to other people. So you can use those to get a measure of how efficient BranchCache is for the BranchCache-enabled resources. Something a lot of people don't know about, but it's an easy way to track what's going on. And then these get folded into some other management software, like our SCOM pack, that can roll it up and give you reporting across a lot of hosted cache servers or clients, if you so choose. Right, but this is the best way to know what's going on. On a hosted cache server, the performance counters will just tell you what's up. And for some people that might have taken this for a spin in Server 2008 R2, we used to reset these every time you rebooted the machine, and we stopped doing that. So if you run the server for a long time, you can get a good sense of how BranchCache is working. I hope that helps. Any other questions right now? OK. I'm going to be hanging out up here for a little bit. I've got nowhere else to go. So please come on by if you want to talk about anything else. Thanks a lot for attending the session. Really appreciate it. Cheers.